Okay, good morning, everyone.
Morning, sir.
Good morning.
Good morning.
Good morning. Today we will be continuing with our discussion on capacitors. Right? We'll be taking a few questions and we'll be discussing them today. So last class we had seen the basics on capacitors, and we'd also seen a few derivations. We'd also seen grouping of capacitors, right? So today we will be extending our discussion with few more questions. So let's look at question number 11. The charge that is deposited on the 4 microfarad capacitor is given by. Okay. Now what we need to find out is we need to find out what is going to be the charge on the 4 microfarad capacitor. Okay. First thing that we will do is, let's find out the effective capacitance of these two capacitors. Can you tell me what is the effective capacitance? How are these two capacitors connected?
Parallel.
Yes, 4 microfarad and 2 microfarad are in parallel, and we know if two capacitors are connected in parallel, then the effective capacitance is given by
C1 plus C2.
Yes. So this becomes 4 microfarad plus 2 microfarad. So we get the parallel capacitance as 6 microfarad. So once it is done, if I'm going to redraw the circuit, right? When we redraw the circuit, we get what? We get a 12-volt battery here. And these two capacitors now have become one capacitance. And apart from that, we have already the 6 microfarad existing capacitance, right? So this is 6 microfarad. And this is the effective combination of 4 and 2, which has become 6 microfarad. And the voltage is 12 volts. Now, can you tell me how these two capacitors are connected? The 6 microfarad and the other 6 microfarad?
Series.
Series, exactly. So in series circuit, what remains same and what splits?
In series, the charge is different and potential different.
Hello? Can you come again, Alvin?
The charge is different and the potential different.
In series circuit?
No. In series.
Here, in a series circuit in resistors, right? You know that current remains same, right? In a series
Yeah, the current.
So here it is charge, right?
Yes, sir.
Yeah, charge remains same in a series circuit, right?
Yes, sir. Charge remains same and the potential difference is different.
Yeah, potential difference between across the capacitors is going to be different, right? So we know that V1 plus V2 will be 12 volts. Now, because the capacitors are equal, now can you tell me in what ratio will the voltages be dividing? How will the voltages divide among the two capacitors? The voltages will divide equally among the two capacitors. Okay. So what is the total voltage? Total voltage is 12 volts. So 12 volts will split up as 6 volts across the 6 microfarad and 6 volts across the 6 microfarad here. Okay, this information is good enough for us. Okay, fine. So now this piece of information is sufficient for us to find out our answer. Okay. Now tell me, in the given circuit, what is going to be the potential difference here? So we already found that the potential difference here is nothing but V2. V2 is equal to 6 volts. Correct? What have we found here? So the 6 volts is going to be the voltage across the 2 microfarad. It is also going to be the voltage across the 4 microfarad. So let's now turn our focus to 4 microfarad capacitor because that's what we are asked. So we are supposed to find the charge on the 4 microfarad capacitor. So the charge on the 4 microfarad capacitor, Q is equal to CV, we already know that. What is the capacitance? 4 microfarad. And what is the voltage? 6 volts. Therefore, the charge on the 4 microfarad capacitance is going to be 24 microcoulomb. So the right answer is the third option. Is it clear, everyone?
Yes, sir.
Yes. First, you find out the parallel combination of these two, you get 6 microfarad. And because both these capacitances are equal, the 12 volt, which is the total voltage, divides equally among the two capacitors, which is 6 and 6. So you understood that the capacitance across the 6 microfarad is 6 volts. 6 microfarad is only obtained as a combination of 4 and 2 in parallel. So the potential difference between these 2 points remains the same. Let's say we call this point as A and B. So that potential difference is 6 volts. 4 microfarad is also connected between A and B. 2 is also connected between A and B only. So the potential difference across the 4 microfarad capacitor will be 6 volts itself, right? And we know Q is equal to CD. So capacitance is 4 microfarad and the voltage is 6 volts. So the total charge on the 4 microfarad capacitor is 24 microcoulomb, right? What will be the charge on the 2 microfarad capacitor if that question is asked?
12.
12 microcoulomb, exactly, right? That is 2 into 6, perfect. What will be the charge on the 6 microfarad, which is here?
36.
36, exactly, 6 multiplied by the 6, perfect. So I hope that is clear to you all. We'll move to the next question. Question number 12. Find the equivalent capacitance between the points A and B for the combination of capacitors as shown in the figure. Now, what can you say about these two capacitors? The 1 microfarad and 3 microfarad are in? Go ahead.
Parallel.
Yeah, they both are in parallel. So what will be the effective combination?
4.
4, yes. Then that capacitance, that effective capacitance and this 4 microfarad, what are they in?
Series.
Yes. 4 microfarad and 4 microfarad in series will give you 2 microfarad. Okay. Similarly, can you now tell me what is going to be the capacitance here? These two are in
Parallel.
parallel. And what is the effective capacitance?
8.
8 microfarad. And that 8 microfarad and this 8 microfarad are in
Series.
series. 8 and 8 in series will give you 4. All right. So at the top, we are having 4 microfarad and another 4 microfarad in series. Below, we are having 8 microfarad and 8 microfarad, which are in series. 4 and 4 in series will give you 2 microfarad. Or you can do 1 by CS is equal to 1 by C1 plus 1 by C2. 8 and 8 in series will give you half of it, 4 microfarad.
4.
Yes. So we have 2 microfarad in parallel with 4 microfarad. Therefore, what will be the answer? 2 and 4 are in parallel. So what will it be? Yes, go ahead. It's going to be 6 microfarad, right? Yes. Let's go to the next question now. In the diagram shown, then what is the net capacitance between A and B in the figure? So now can you tell me which are the capacitors? What about these two capacitors?
Series, sir.
Yeah, they are in series, right? So 6 and 3 in series will give you 2 microfarad. You can verify. So 1 by CS is equal to 1 by 6 plus 1 by 3. LCM is 6. So it's 1 plus 2. So that's 3 by 6, which is 1 by 2. Or CS will be 2 microfarad. Therefore, the top capacitor becomes 2 microfarad. And that top capacitor and this one, they both are in
Parallel.
Parallel.
I guess what you can do is you can keep your mics open, okay, so that you can interact freely. We will avoid that delay.
Yes, sir.
Okay, great. So 2 microfarad and 1 microfarad are in parallel. So what will be the effective capacitance? Okay, let's go step by step. So first step. So we are just simplifying the first 2 capacitors on the top. So the effective capacitance becomes 2 microfarad. Then that capacitor is in parallel with 1 microfarad capacitor. Right? Then that combination is in series with 6 microfarad. Do you agree? So this is the combination that is in series with 6 microfarad. Then that whole thing is in parallel with the 2 microfarad capacitor. And then this whole thing is in series with the final 2 microfarad capacitor. So this is the scenario, right? So 6 and 3 has become 2 now. Now this 2 and 1 which are in parallel will give you a 3. So we have a 3 microfarad and a 6 microfarad here. What I have done is I have simplified these two. Got it? We have got a 2 microfarad here. Then finally you have a 2 microfarad. So this is the next step, right? So this is A, this is B. Now what about this 3 microfarad and 6 microfarad? They both are in series once again. Already we had solved this, and 3 and 6 are in series. The result that you are going to get is 2 microfarad, right? So in third step, if you see, so this is 2 microfarad, one more 2 microfarad is below. Then we have another 2 microfarad, right? So this 6 and 3 have become 2 microfarad now. 2 and 2 are in parallel. So 2 and 2 in parallel will become 4, right? So the fourth step is, just for you to clearly understand, I am writing it in different steps. So 2 and 2 in parallel will become 4 microfarad. And the other one is 2 microfarad, right? So this is the last step. So your 1 by CS will be equal to 1 by 4 plus 1 by 2. So it's 1 plus 2 divided by 4 after taking LCM. 3 by 4. You should not forget to take the reciprocal. So the capacitance is 4 by 3 microfarad. I should take the options. If let's see if the right option is given. Yeah. So which is the right option? 4 by 3 microfarad. I'll explain once again. 6 and 3 are in series. The effective capacitance will be 2. That 2 and 1 are in parallel, so it will become 3. 3 and 6 once again come in parallel, so it become 2. 2 and 2 in parallel, I'm sorry. 6 and 3 in series, it becomes 2. 2 and 1 in parallel becomes 3. 3 and 6 in series becomes 2. 2 and 2 in parallel become 4. 4 and 2 in series will become 4 by 3. All right. Now, one more way you can do it is, instead of writing 1 by CS, what you can do is, you can do C1, C2 by C1 plus C2. So, in this case, it is 4 into 2 by 4 plus 2. So, it will be 8 by 6. You will get 4 by 3 straight away. There's no need to take reciprocal, right? So, this way also we can find the effective capacitance when two capacitors are connected in series. Is it clear, everybody?
Yes, sir.
Yes. Okay. You're also noting it down, or you need some time for writing down? Or shall we proceed? You noted down?
Noting down, sir.
Okay, okay. Shall I wait?
Yes, sir. 1 second.
Yeah, sure, please. You can tell me which step you are in. I will just move the page accordingly.
A second step, sir.
Okay.
Completed, sir.
You completed the whole sum?
Yes, sir.
Okay. Let's move on to the next one. Okay. Question number 14. Two uncharged capacitors of capacitance C1 and C2 are connected in series and they are charged with a battery of EMF V volts. At steady state, the potential difference across the capacitor of capacitance C1 is, okay. So we have two capacitors which are connected in series to a battery. The capacitors are C1 and C2. And let's say the EMF is V, right? Now, this is what kind of a circuit? The capacitors C1 and C2 are connected in series. So, what will be same in that circuit? And what will be different for two capacitors? Yes, come on. What can you say about the charge on both capacitors?
Same, sir.
Sorry?
Charge will be the same.
Yeah, charge will be the same on both the capacitors, right? Because they are connected in series. And what will be the divide?
Potential difference is different.
Yes, the potential difference, let it be V1 and V2, that will get divided among the two capacitors, right? Okay. So V is equal to V1 plus V2, we know that, right? And what is the relationship between these three variables, V1, C1 and Q, and V2, C2 and Q? We know that Q is equal to C1 into V1 in case of the first capacitor, correct? And in case of the second capacitor, Q2, which is Q itself, is equal to C2 into V2, correct? Now, what is asked in this question is they have asked you what is the potential difference across the capacitor C1. V1 is asked, right? Suppose, can you tell me what is the total charge in the capacitor, right? So we know what is the effective capacitance of these two capacitors, CS. CS will be equal to C1, C2 by C1 plus C2. That's the total capacitance. And the total voltage is V. So the total charge will become equal to, total charge is nothing but the total capacitance into the voltage. The total capacitance is given by C1, C2 divided by C1 plus C2. That's the total capacitance multiplied by V. So this will be the total charge. Correct? Now we want to find out V1, let us say. What is V1? V1 is nothing but the charge on the capacitor divided by its capacitance. What is the charge on the capacitor? It's going to be Q itself divided by C1, because we know Q is equal to C1 V1. So V1 will be equal to Q divided by C1. And Q we already found. What is Q? C1 C2 divided by C1 plus C2 into V. That is your Q. Already there is a C1 in the denominator. The C1 and C1 will cancel. Therefore, what is going to be your V1? V1 is going to be C2V divided by C1 plus C2. Is it clear? So which option is correct? The fourth option is going to be right. Let me explain what I have done once again for you. So if you see the two capacitors of capacitance C1 and C2 are connected in series, and they're connected to a battery of voltage V. So capacitance of the first capacitor C1, second capacitor C2, and you know in series circuit the charge remains the same. So it is Q on both of them. And the potential divides, so let it be V1 and V2. We know that V is equal to V1 plus V2, right? Now, what is the effective capacitance of two capacitors connected in series? We know that it's 1 by CS is equal to 1 by C1 plus 1 by C2. When you simplify, you will get CS is equal to C1 C2 by C1 plus C2. And what is the total charge? It's nothing but the total capacitance into the total applied voltage. Total capacitance we have seen is what? C1 C2 by C1 plus C2 into the total voltage, which is V. Now, with this knowledge, let's find out what is V1. What is the equation connecting all these three variables? Q is equal to C1 V1. So from there, what will be V1? V1 will be Q by C1. Q divided by C1. Already we know the expression for Q. What is it? C1 C2 divided by C1 plus C2 into V. That whole thing divided by C1. This is what is Q. Q divided by C1. So on C1 gets cancelled. So you get V1 is equal to C2V by C1 plus C2. Clear? Have you understood?
Yes, sir.
Yes, ma'am.
Yes, sir.
Very good. Now, can you tell me, without solving, can you tell me what is going to be the voltage of V2? Just from observation, you can say. V1 is C2V by C1 plus C2. So what should be V2? Suppose if I asked V2, then what will be the answer? V2 will be C1V divided by C1 plus C2. So basically, if the question is given when two capacitors are connected in series, then directly you can take, if you want V1, what you do is, the other capacitance, what is the other capacitance? C2. C2 multiplied by the total voltage, V, divided by the sum of the capacitances. That's all. So if I have two capacitors, C1 and C2, and the voltage is V here. Suppose I want V1, then V1 will be nothing but the other capacitance. What is the other capacitance? C2 into, what is the total voltage applied? V, divided by the sum of the capacitances C1 plus C2. Similarly, what will be V1? I'm sorry, V2. V2 will be the other capacitance. What is the other capacitance? C1 into V divided by the total capacitance C1 plus C2. Is this clear? Directly you can remember this and you can solve the problems. Clear?
Yes, sir.
Yes. Have you taken it down? Or shall I give you a minute?
So 1 minute.
Yeah, please. Let me know once you're done, then we'll go to the next question.
Done, sir.
Yes, ma'am. So let's go to the next question now. Let's read this question now. 4 condensers, each of capacity 4 microfarad, are connected in as shown in the figure. Vp minus Vq is 15 volts. What is the energy stored in the system? Okay. Now, Vp minus Vq is 15 volts is same as connecting this to a battery. If you are understanding, you can write it like this. Okay. So potential difference between P and Q is 15 volts. And you have a system of capacitors. Condensers or capacitors mean one and the same. Capacity or capacitance also means the same, right? 4 microfarad is going to be the capacitance of each capacitor, which is shown here. Now we need to find out the total energy stored in the system. So I hope you remember the formula for the total energy stored in the system. The total energy stored in the system is given by 1 by 2 C V square. So this capacitance is the total capacitance or the effective capacitance. Total V we know, the total potential difference between P and Q is 15 volts, right? So the only thing that we don't know is the capacitance C total. So that is nothing but the effective combination of these 4 capacitors. Now first step. Can you tell me how are these 2 capacitors connected?
Parallel.
Parallel, right? So 4 and 4 in parallel will be 8 microfarad. Then once you simplify that, you will have a 4 microfarad, then a 8 microfarad, and once again a 4 microfarad. So you have a 4 microfarad capacitor. In between you have a 8 microfarad capacitor, and then finally a 4 microfarad capacitor. All of them are connected in series, and that combination is connected between 2 points which have a potential difference of 15 volts. For convenience, I have told you, you can consider it equivalent to having a battery in between, whose value is 15 volts, right? Okay. So now we need to just find out what is the value of effective capacitance C. So 1 by Cs is what we need to find out. So that is 1 by 4 plus 1 by 8 plus another 1 by 4. So that will be 1 by 4 plus 1 by 4 is 2 by 4. 2 by 4 is nothing but 1 by 2. So 1 by 2 plus 1 by 8. So LCM is 8. 4 times this is 1 time. So it's going to be 5 by 8. So your effective capacitance is the reciprocal of this. So your total capacitance or CS is going to be equal to 8 divided by 5 microfarad. Or it is 16 by 10, which is 1.6. Correct? This is the total capacitance. But we need to find out what is not just the capacitance, but the energy also, right? So we will use this expression. So energy is equal to half CV square, the total energy, total capacitance multiplied by the potential difference square. So that's nothing but half into capacitance. Already we have found it is 8 by 5 microfarad. and voltage is given 15 volts. So it's 15 into 15. Right? That's the simplification of this. So this is 3 times and this is 4 times. Right? So it is 15 into 4. That's going to be 60. 60 times 3 will be 180. So it is 180 microjoules. Right? Now the answer is expected in ergs. What is the relationship between ergs and joules? You can see it here. 1 erg is equal to 10 power minus 7 joules. Right? Or in other words, 10 power 7 erg is equal to 1 joule. So 1 joule is equal to 10 power plus 7 ergs. So this is nothing but 180 into 10 power minus 6 multiplied by 10 power 7 ergs. 10 power minus 6 into 10 power 7 is 10. So 180 multiplied by 10 gives you 1800 ergs. So that's the required answer. So which option is right?
Option B.
Option B, second option, right? So now you can note it down. Let me know if anything is to be repeated again. So the idea is these two capacitors are in parallel. Effective capacitance becomes 8 microfarad. All these 3 capacitors are in series 8, 4, and 4. So the effective capacitance becomes 8 by 5 microfarad. Once you know the total capacitance, you already know the voltage, which is 15 volts. So you can use the formula half CT CV square. So we are using that when we simplify, and then conversion from joules to ergs. 1 joule is equal to 10 power 7 ergs. Therefore, it is 1800 erg. Is it clear to you? You take it down. Once you are done, let me know. Then we'll proceed to the next question. In case you want me to zoom the screen, let me know.
Completed, sir.
Completed? Yes. Okay. We'll go to the next question. Okay. Now, what's the effective capacitance between the points X and Y? Okay. I think you remember Wheatstone's bridge, right? In electricity.
Yes, sir.
Yeah. So if you look at the Wheatstone's arrangement, in electricity, if you see, you will have 4 resistors connected like this. There will be 1 resistor connected here, and you have a battery here. Let me call these resistors as P, Q, R, S, and let's say this is P, and let's say this resistance is X. Okay. Now what happens is, in case if this resistance divided by this resistance is equal to this resistance by this, if P by Q is equal to R by S, or you can say P by R is equal to Q by S, then these 2 points will be at the same potential. If this happens, if P by Q becomes equal to R by S, or P by R becomes equal to Q by S, then these 2 points here, let's say this is A, this is B, this is C, and this is D. C and D will be at the same potential. There will be no potential difference between C and D. Because of that, there will be no current which will flow through the resistor X. So if no current is flowing through the resistor in a circuit, then as far as analysis is concerned, you can literally remove that resistor from the circuit and analyze it. Which means the current I1 which enters here without branching into this path DC, it goes as I1 itself. Similarly, a current which comes here I2, let us say, that also does not enter CD path and goes as I2 itself. And I1 and I2 combine and give you I here, correct? So the main point, the main concept to understand is the middle capacitor resistor can be removed if balancing condition is satisfied, which means then the current through the resistor X is 0. So that resistor X can be removed and then the problem can be solved. Similar scenario happens in case of capacitor also. So in case of a capacitor, if an arrangement like this is there, right? And let's say this is C1, this is let's say C2, this is C3, this is C4 and C5. Suppose the ratio of the capacitances C1 and C2 and C3 and C4 are going to be equal. C1 by C2, let's say, is equal to C3 by C4. Then no charge is stored in the capacitor C5. So because of that, if C1 by C2 is equal to C3 by C4, then this capacitor can be removed from the circuit and it can be analyzed. All right. So this is the concept we are going to discuss in this question. If you carefully analyze, this represents a Wheatstone's network. How do I say that? Let's see. Okay. So let's first write down all the points which are there here. What are the points here? A, C, B, and D. So what I'm going to do is I'm going to write this point A here. I'm going to write this point B here. Okay. So I'm writing the point A. I'm writing the point B here. Okay. Let me write the point C here and D here. Okay. Let's say C here and D here. Okay. Now tell me, between A and C, we have a capacitor, correct? So between A and C, I'm drawing a capacitor. And what is its value? It is C3, which is 6 microfarad. 6 microfarad, correct? Then I'm having a capacitor between C and D. How much is it? That is also 6 microfarad, C5. So this is C5 and that is also 6 microfarad, right? Then now I'm going to draw a capacitor between C and D, which is 6 microfarad, C4. This is C4, which is also 6 microfarad, correct? Okay. Then I'm going to draw another capacitor C2 between B and D, right? What is this? This is C2, which is equal to 6 microfarad, correct? And finally, I'm going to draw another capacitor which is between A and B, correct? So between, I'm sorry, A and B, yeah, okay. Wait a minute. A and C we have completed. C and B, okay. So C and B was supposed to be, C and B is completed. C and D is also completed. Okay. Fine, here in this case, okay. This point is B and this point is D, all right? So finally we are going to do from A and B. So from A to B, there is one capacitor. So which is going to be called as C1, which is 6 microfarad. So can you see this arrangement here? Is it not a Wheatstone's bridge? Have you been observing this, students?
Yes, sir.
Yes, it is
Yes,
a
sir.
Wheatstone's bridge, right?
Yes,
A
sir.
and D, correct. Now, can you tell me what ratio must be satisfied so that I can remove the middle resistor, middle capacitor? C3 by C5 must be equal to what in this case? C1 divided by C2, correct?
Yes, sir.
Yes. But is it true or not? 6 by 6 is equal to 6 by 6, correct?
Yes, sir. it is.
Therefore, which resistor can I, which capacitor can I remove? We can remove the middle capacitor. C4 can be removed. So once I remove this middle capacitor, how does the circuit look like? You have A, you have C, you have B, you have D. So you have one capacitor here, one capacitor here, one capacitor here, and one capacitor here. And D is connected to Y. D and Y are basically same points only, and X and A are same points only. So this capacitance you need to find out. This is very simple, right? What can you say about these two capacitors? Yes, tell me, students.
Connected in series, sir.
Yeah, they are connected in series. Both are having 6 microfarad and 6 microfarad. So the effective capacitance will be 3 microfarad. All right. Similarly, below if you see, these two capacitors are connected in
Series.
series. So 6 and 6 again. So the effective capacitance will be 3.
3.
So the top you have 3, bottom you have 3. That both capacitors, how they are connected?
Parallel.
Parallel. So 3 and 3 are connected in parallel. So what will be the total capacitance?
6.
6 microfarad. So that's the answer. Is it clear to you?
Yes, sir.
Yes, please make a note of it. So the way the circuit is drawn, if you just redraw it, then you will understand it is a Wheatstone's network. Just by looking at it, you may not be able to guess that it is Wheatstone's bridge. But if you just redraw it, you will be able to get it. Once you have taken down completely and understood it, then we'll proceed to the next one. So how I am redrawing the circuit, is that clear to you?
Yes, sir.
Yeah.
Completed, sir.
Completed now? Okay, great. So let's move on to the next one. Let's look at question number 17 now. What is the equivalent capacitance between A and B? Okay. First, can you tell me about these two capacitors, how they are connected?
Series, sir.
Yes, they both are in series. 2 microfarad and 2 microfarad in series will give you 1 microfarad. So I'll just redraw the circuit. These 2 microfarad and 2 microfarad have become 1 microfarad. Right? So this is 1 microfarad, and already there is a 1 microfarad which is there. And here you have 1 microfarad, and here you have 2 microfarad. So this is step 1, right? Is step 1 clear to you?
Yes, sir.
Yes. Okay. Now, can you tell me what about the 1 microfarad and the 1 microfarad here? How they are connected?
Parallel.
They are going to be in parallel, right? So 1 microfarad and 1 microfarad in parallel gives you 2 microfarad. So this is a 1 microfarad here, and this 1 and 1 have become 2 microfarad, and here you have a 2 microfarad. What can you tell about these two capacitors?
Parallel, sir.
See here, it is a single path. There is no deviation, correct or not? They both are connected in one line, correct or not? No deviation from anywhere, right? No deviation into any other path. Correct or not?
Yes, sir.
Then what is it?
Series.
Series, right? So 2 microfarad and 2 microfarad are in series. So 2 and 2 in series will give you 1 microfarad. If you want, you can do the calculation yourself. So this is A, this is B. So this is 1 microfarad. And this 2 and 2 is going to give you what? 1 microfarad. And what about this 1 and 1? What about this 1 and 1? They are in parallel, so you will get 2 microfarad. So the answer is 2 microfarad. Is it clear?
Yes, sir.
Yes. Let's go through it once. So we are supposed to find out the equivalent capacitance. As you can see, we start with these two. These two are in series because there is no deviation of the, in a sense, there is no other parallel path or any other path. If you consider resistors, right, the current entering here will not branch anywhere, correct, like that. So the two capacitors will have the same charge on them. So these two capacitors are in series. Effectively, it will become 1 microfarad, and that 1 microfarad and the 1 microfarad here, they will be in parallel. So you will get 2 microfarad, and that 2 microfarad and this 2 microfarad, it's the same path, so it is in series. So 2 and 2 in series will give you 1. Then 1 and 1 in parallel will give you 2 microfarad. Is it clear to you? Take it down. If you're once you're done, let me know. Any doubts are there in this? Let me know. I will repeat it again.
Completed, sir.
Completed now? Okay, fine. So let's go to the next one now. All right. So you have a setup like this, right? So there is a lot of symmetry in this circuit. That means if you draw a vertical line here, if you cut it along that line, left side and right side look identical. Yes or no?
Yes, sir.
Yes. This means all these potentials will be same. At all these points, the potentials will be same. Suppose if it is V here, here also it will be V, here also it will be V. So what is the next step? So if it is V, right, if the potentials are going to be same, then between this point and this point, is there any potential difference? Tell me.
No, sir.
No potential difference, correct? Yes?
Yes.
So there is no potential difference. If there is no potential difference, in case of resistors, we will understand that there will be no current which will flow, correct or not?
Yes, sir.
In this case, there will be no charge that will be stored in this capacitor. Therefore, these two capacitors, there will be no charge which will be stored, so they can be removed from the circuit. Are you clear?
Yes, sir.
Yes.
Yes. This is based on the symmetry. So what will happen to the circuit now? On the top, you have two capacitors. In the middle, you have two capacitors. Bottom, you have two capacitors. That's all. The sum becomes a very simple sum to solve. Is it clear?
Yes, sir.
Yes. So what about the top two capacitors? How are they connected?
Series.
Series. What about these two capacitors?
Series.
Series.
Yeah, all these capacitors which are in the branches are connected in series among each other. So what will you get? You will get, when C and C are connected in series, you will get C by 2. So your capacitance will become C by 2. And all these three capacitors, how they are connected?
Parallel.
They are connected in parallel, then the effective capacitance is simply the addition of the three capacitances. So it will be just C by 2 plus C by 2. Plus C by 2. So what will the answer be? Three C by 2. Is that clear? You understood how to solve such questions?
Yes, sir.
Yes. So what is the key thing to do understanding this question? In this question, if you draw a vertical line, right, in the middle, then both the sides are exactly identical. They are mirror images of one, correct? One is the mirror image of the other, correct?
Yes, sir.
In that case, at each of those points, the potential will be same. So because the potentials are same, there will be no charges that will be stored in the middle capacitors. So those can be removed from the circuit. Once you remove them, then this becomes a very simple problem. Is it clear?
Yes, sir.
Yes. So what you can do is you can just solve it. Once you're ready, then we'll go to the next one.
Done, sir.
Done. No? Go to the next question. Okay. What is the equivalent combination of the combination shown in the figure? Equivalent capacitance of the combination shown in the figure. Okay, now let's see here. Now let me call this point as A. Now can you tell me what is this point going to be? See here, only if I connect a capacitor in between or a resistor or a battery, then the potential will change. So if the potential at this point is A, what is the potential at this point, other point? This will also be A. Along this wire, what is going to be the potential?
Yes, sir.
A only. Right? The moment it crosses the capacitor, it's a different point. Because there will be a potential dropped across the capacitor so that you will have a different point there, right? So let's call this point as B, okay? Then what is this point?
B.
B, yes. Potential wise, what is this point?
B, sir.
B itself, right? Because as I'm drawing this line, there is no capacitor in that path, right? What is this point?
B itself, sir.
B itself. What about this point as far as potential is concerned?
B only, sir.
B only, very good, right? So totally there are only 2 points in this sum. What are they? One is A.
A
the
and B.
other one is A and the other one is B. Right? Right? Now, what can you tell about anybody, can tell me what about this capacitor? This capacitor is connected between which points?
B and B, sir.
B and B. So is there any potential difference?
B and
No, sir.
No potential difference is there. If no potential difference is there, will there be any charge stored in the capacitor?
We can remove it, sir.
Very good. So we can remove this capacitor because there is no charge stored in this capacitor. That's all. So effectively, there are only 2 capacitors which are there. So what is the effective capacitance? C and C are in parallel. So what is the effective capacitance? C1 plus C2, 2C. Therefore, the right answer is 2C. So the sum is basically given to help you understand that if the potential difference between the 2 points of the capacitor is 0 or 2 points are connected to the same potential, then there is no charge stored in the capacitor. You can remove that capacitor from the circuit. Clear?
Yes, sir.
Yes, that's all. So note it down. Once you're done, let me know. We'll go to the next question.
Completed, sir.
Completed? Okay. Let's go to the next question now. For the circuit shown, the equivalent capacitance between 2 points P and Q is. So this I want you to try it yourself. I'll give you a minute or 2 for trying it. Very similar to the previous sum. You have to find out what are the different points which are there and then redraw the diagram. Then we will solve it. Okay, I'm just I've drawn here. Now you can see that these two capacitors are in series, correct? C and C in series, so it becomes C by 2. So that I have drawn here. So that capacitance is C by 2. Okay. Rest of them are all C, correct?
Yes, sir.
Yes. Now let's see how many points are there, how many points of different potentials are there, right? So let's start from Q. So from Q, I'm having a capacitor. Then the other end will be a different point, right? What will be this point? Is it Q or something else? The one which I have drawn with red color. Is it Q or different point?
Different points.
Different point, right? So let me call it as R. The same wire is being connected. Can you tell me what is this point?
R.
R itself, right? Because it's connected, there is a wire which is connecting them, right? So what is this point? What is all this point?
R, sir.
R itself, right? Okay. So all these points are R. I hope it's clear to you, right? What is this point? This is P, right? What is this point?
P.
P. Till here it is P. Because they are simply connected by a wire, right? So what is this point?
P.
P. Very good. Okay. So we are done with finding out what are all the different points which are there, correct? So how many points do we have? How many different electrical nodes we have? P, Q and R, correct? So we have a point P. Then we have a point R. Then finally we have a point Q. Correct? Okay. Now, what can you say about this capacitor, which is here? It is connected between which points? The capacitor which I have marked with yellow. It is connected between
R and R.
R and R. So what can you say about it?
It's removed, sir.
It can be removed because there will be no charge stored in it. If I can remove it from the circuit. Very good, that's all. Very good. So now, between R and Q, how many capacitors I have? From R to Q, how many capacitors are there?
2 capacitors.
Here two.
I mean-
Here I have Q is here. Here is R. How many capacitors are there?
Answer.
1
Only-
capacitor.
Only one capacitor is there. Which is having capacitance C, right? Now look at P to R or P and R, between P and R. Between P and R, you have what? One capacitor here. And between P and R, what do you have?
One capacitor.
Between P and R. So how many capacitors you have between P and R? P and R or R and P, doesn't matter.
3, sir.
Three
Capacitor.
capacitors are there between P and R. So between P and R, one capacitor. Between P and R, another capacitor. Between P and R, another capacitor. So the two endpoints must be P and R. Is it clear to you? Understood? On all the three capacitors, the endpoints must be P and R. So this must be P. This must be R. P, R. P, R. Understood?
Yes, sir.
How many capacitors are there? Three capacitors.
Three.
So what about these three capacitors? What can you say about these three capacitors?
Connected in parallel.
Parallel. So it will be effective capacitance will be
C plus C plus C.
exactly. So it will be 3C and this. What about 3C and C? How are they connected?
Series.
Series. Therefore, the total capacitance is equal to 3C into C divided by 3C plus. So what will it be? 3C into C divided by 4C. So and C will get cancelled. So what is answer?
D, sir. DC by
3C by 4.
DC.
The right answer is 3C by 4. Did you understand clearly?
Yes, sir.
Yes. Yeah. You can take it down. Once you're done, let me know.
Yeah, sir.
Any doubts are there? Let me know. I will repeat it. Are you able to understand this one, everybody?
Yes, sir.
Yeah. Do you want me to repeat this? Or is it clear?
It's clear, sir.
Excellent. Excellent. Yeah. Once you complete, just let me know.
Done, sir.
And now, okay. Now let's go to the next one. 21st question. We'll be doing it in the next class. We'll be doing Dielectrics, along with that, we'll do the 21st. 22nd onwards, we'll continue. Okay. So here we have two batteries, 6 volt and 16 volt. What is the potential difference across the 2 microfarad capacitor as shown in the diagram? So you have a capacitor here. Correct. Okay. Fine. Now, this is just one loop, right? One loop. Here we need to find out the potential difference across the 2 microfarad capacitor. Correct. Now, can you tell me what will be the charge? Will the charge on 2 microfarad and 3 microfarad will be same or not? How are 2 microfarad and 3 microfarad connected?
Parallel.
Are you sure, Alvin?
Series, sir.
Series, no, because this is just one loop,
Oh, okay, sir.
right? So there is nothing wrong if I draw it like this. Correct? 6 volts, 16 volts, of course. The direction will be different. And 2 capacitors. This is the same as the other diagram, all right? Because it is a single loop. When will 2 capacitors be in parallel? When they are connected between the same 2 points, like for example, A. Now these 2 capacitors are in parallel because they are connected between what are the ends of A and B? I mean the first capacitor, A and B. Now what about this capacitor? That is also A and B. In this case, you can say the capacitors are connected in parallel. Clear? So for here, the
Yes, sir.
capacitors are connected in series, right? First thing to understand. Okay. Now, this is very similar to how you will solve your problem on Kirchhoff's voltage law in using Kirchhoff's voltage law in electrical circuit. For example, let me give you an example. Let's say the voltage across the resistors are V1 and V2. This is 16 volt. This is 6 volts. Then how will you write the equation? You will form a loop, right? Usually you take it from positive to negative of the bigger battery. So bigger battery is 16 volt. So you will take the current to be flowing in this direction. Then what will you do? When the current is crossing the battery, minus to plus. Therefore it will be plus 16 volt for the first battery. Then as the current is moving here and flowing through the other battery, 6 volt battery, it is first seeing the positive terminal and then the negative terminal. So it is a decrease in potential. First positive terminal, then second negative terminal. So it's a decrease in potential. So it will be minus 6 volts. And this will be equal to the voltages across the resistors. So V1 plus V2. This is how you will do it in your resistive networks. Yes, do you remember? If you had solved such questions in your class. If not, we will do it, no problem. Should I repeat what I said, guys?
Yeah, sir. Once again, please.
Yeah, once again, I'll tell you, right? For example, if you have a resistive network like this, right? Let's say this is a resistive network here. Because once you know, understand for this, then you can extend it to your capacitor networks. So in resistive network, what happens is single loop for writing Kirchhoff's KVL, Kirchhoff's voltage law equations, right? How you do is, so the concept is very simple. It's based on law of conservation of energy. The energy given by the battery is equal to the energy consumed by the resistors, or in other words, the voltages which are provided by the battery will be equal to the voltages consumed by the resistor, because you know resistors will consume power, right? So if you see, what is the voltage provided by the battery? Let's see, right? Net EMF, right? So for that, you will take one direction of the loop current. You call something called loop current, right? You can either take it in clockwise direction or anti-clockwise direction, preferably in a direction from positive terminal of the battery to the negative terminal of the battery. So we start from the positive terminal of the, so here we have two batteries, one is 16 volt, another is 6 volts. If you take 16 volt as a reference, it will go in clockwise direction, as I have drawn. If you take the 6 volts battery, then it will go in the anti-clockwise direction, because positive is here. But which one am I going to take? I'm going to take the bigger battery, which is 16 volts, like compared to 6 volts. So I have taken which direction? I have taken clockwise direction. So when I'm going in the clockwise direction, if you can see, as I'm crossing the battery in the clockwise direction, first I'm seeing which terminal? Negative or positive? As I'm entering the 16 volt battery in the clockwise direction, first I'm seeing the negative terminal or a positive terminal?
Negative, sir.
Yes, then after that I'm seeing the
Positive.
positive terminal. So it's negative to positive, right? So negative is lower, positive is higher. So I'm going from lower to higher potential, correct or not?
Yes, sir.
Then I should put a plus sign. Whenever there is an increase in potential, I'll put a plus sign, okay? Is it clear?
Yes, sir.
Yes. Now, as I'm going into the other battery, in the clockwise direction, when I'm entering into the 6 volt battery, which terminal am I seeing first?
Positive.
Yeah, I'm seeing the positive terminal first. Then I'm seeing what?
Negative.
So which means what? First higher potential, then lower potential. So as I'm moving in that direction, it's higher potential to lower potential. So it's a decrease in potential or increase in potential?
Decrease in potential.
Yeah, therefore I will put a minus sign. Whenever there is a decrease in potential, I'll put minus. Whenever there is increase in potential, I'll put a plus. Is it clear?
Yes, sir.
Yes. So 16 volt minus 6 volts. That is the voltage supplied by the battery. That will be equal to the voltage consumed by the components. What are the passive components here? Resistors or capacitors. Okay. So here, what is the voltage across the resistor here? R1, V1. What is the voltage across the resistor R2? Let's say this is R1 resistor, this is R2 resistor. Understood? So your total voltage 16 minus 6 is equal to what? The total voltage that is getting consumed. What is it? V1 plus V2.
V2.
Yes. So 16 minus 6 is 10 volt. So 10 volt is equal to V1 plus V2. What is the V1? See here, these two resistors are, how are they connected? They're connected in series or they're connected in parallel?
Series.
Series, absolutely, because it is one single loop, same current will flow. So what will be the relationship between voltage, current and resistance? You have learned Ohm's law. V is equal to I into R. So what will be V1 equal to I into R1 plus what will be V2 equal to I into R2. Are you understanding?
Yes,
Yes,
sir.
sir.
Exactly the same way we have to solve this question also. So let's say the voltage across this capacitor is V1. Let's say the voltage across this capacitor is V2. Yes. Now, how are these two capacitors connected?
Parallel.
Yes, ma. Tell me, is it in parallel? You said these two resistors are connected in what? Series.
In series, sir.
Because it's a single loop. It's a single loop. Therefore, they both are connected in what? How are the two capacitors connected?
Series.
Yeah, they are connected in series because they are in one loop, right? I told you already. When will we call two capacitors to be in parallel? Only if they are connected between the same 2 points. So this is B, this is A. Then only you can say. So here, if you see this is A, this is B. This is some other point C, correct? Because there is a battery in between. And this point is B. This point is not B. This point is D, correct? So can you say they both are in parallel?
No, sir.
Right? Okay, fine. They are in series here. So now, same, going by the same logic, right? KVL, Kirchhoff's voltage law, when you apply, what will we get? Again, by same logic, it is 16 minus 6. You understood 16 minus 6 here? Did you understand 16 minus 6, how we are getting?
Yes, sir.
Yes. Same logic, we are getting 16 minus 6 here is equal to V1 plus V2. What is the charge stored in the capacitor? Are the two capacitors having the same charge or different charge?
Different charge.
The two capacitors, how they are connected? How are the two capacitors connected? Are you all listening? I'm not listening answers from everybody.
Yes, sir.
How are the
Yes,
two
sir.
capacitors connected?
Series.
Series. Then what will be same in them?
The charge will be the same.
Charge will be the same. So both of them will have the same charge. Got it?
Yes, sir.
Yeah. What is the relationship between charge, capacitance, and voltage? Q, C, V. What is the relationship between them? I'm waiting for your answer. Q, C, V. What is the relationship between them? Why nobody is answering, ma'am? Akila, are you there?
Yes, sir.
Yeah. What is the relation between Q, C, and V?
Q is equals to CV, sir.
Yeah. So many times we have seen in this entire exercise, right? Why so much time? Good. Anyways, good. Q is equal to C by CV. So what is V equal to?
Q by C.
Yeah,
by
Q by C. Yes. Okay. So what is V1? What is V1?
Q by C.
Yes, ma'am. Q by C1. What is V2?
Q by C2.
I
by
C2.
C2. Yes. So that is equal to 16 minus 6 is what?
10.
10. Yes. Okay. C1 and C2 are already given to us. What is it? What is Q? What is C1?
2 microfarad.
Yeah, C2 is?
Microfarad. 3.
3 more.
Yes. Just we simplify, we'll get Q now. So multiply by 6 micro on both sides. Then you will get 60 micro in the right and left hand side. Right side it will be 6 micro into Q by 2 micro. 6 micro into Q by 3 micro. Basically, I am taking LCM, that's all. So this will be how many times? 3 times. This will be 2 times. So 60 micro is equal to 3Q plus 2Q. What is it? 5Q.
5.
So what is Q equal to?
60 by
60 by 5. So it will be
12.
12 microcoulomb. Yes or no?
Yes, sir.
Yes. So what is asked in the question? Potential difference across 2 microfarad is asked. Potential difference across 2 microfarad is how much? Is it not V1?
Yes, sir.
Yes. That will be V1. So V1 is nothing but
Q by C1.
What is Q?
12.
12 microcoulomb divided by C1. What is C1?
2
2
microfarad.
microfarad. So this gets cancelled. You get what? 6. So V1 is equal to 6 volts. That's the answer. So which option is right?
Option C.
Third option.
C. Yeah. So just note it down. Just take it down. We are just using Kirchhoff's voltage law. So 16 minus 6 is the total EMF, that is equal to V1 plus V2. V1 is Q by C1, V2 is Q by C2. C1 is 2 microfarad, C2 is 3 microfarad. So from this we are getting the value of Q. Once you find Q, then V1 is already Q by C1. So you're just substituting the value of found Q, you get V1. Just take it down. Let me know once you're done. Any part you did not understand, just let me know. Once again, finally, I'm asking, how are these two capacitors connected?
Series.
Yes.
Series.
You're clear, right? Okay.
Yes, sir.
Done, sir.
Done, huh? Okay, excellent, excellent. So go through these questions once again, okay? All these questions, you redo them so that you will get good idea, okay?